Hello, this is Jack Jackson back again. In this section, we look at another example of a one-sample t-test, this time for a right-tailed test. This time, let's go ahead and use the built-in applications on your calculator, and you should actually be able to do this one without help. So what I want you to do is actually think of this one as an exercise that you can practice on. As I produce the problem, you work it, and then check your answer against the provided solution. T-tests are so important that I'm going to make sure that we look at multiple examples, including two-tailed, right-tailed, left-tailed tests on the one-sample test. And this particular one is a one-sample right-tailed test. Here's the problem. A psychological test is given to determine the psychological status of an individual. By the way, notice that when we're looking at our different types of problems for t-tests or hypothesis tests in general and confidence intervals in general, notice that these can come from a wide variety of different topics. So really, an introductory statistics course like this is appropriate whether you're doing a major in business or a major in medicine or health sciences or science, biology, mathematics, any area at all, including, for example, education, psychology. There's examples of this everywhere. So pretty much any field that you can think of, they're going to be examples. And I'm trying to pick a few from different fields to give you an idea that this works. So anyway, let's get into the actual problem and have you do it yourself. A psychological test is given to determine the psychological status of an individual. A subject with a score of 40 is considered normal. Higher scores indicate more psychological problems. A group of 23 patients with mild head trauma were given this test, and the sample resulted in a mean score of 48.43 and a standard deviation of 20.76. At the 5% significance level, is there enough evidence to say that the patients with a mild head trauma score higher on this particular psychological status? All right, your turn. You do this one. Check your work when you come back. Press pause now. Well, the first thing we always have to do is decide what kind of test we're going to use. Or is it a hypothesis test? Is it a confidence interval? This one is a hypothesis test, and we're testing means of one sample against a hypothesized mean. That's narrowing it down to a z-test or t-test for what we have, at least for the parametric versions that we've talked about. The scores have to have a normal distribution for those. So, well, the scores don't have to have a normal distribution, but the sample means do. In this case, the individual scores are normally distributed. I think that says that somewhere. Let's see. I'm not sure if it says that. Hang on a second. Subject trauma. Yeah, here it is, the last sentence. Assume that the scores on the test are distributed normally. So with that assumption, then we know for sure, regardless of the sample size, that the distribution of sample means is normal. With a size of 23 for the patients, that's for a sample size, that's pretty close to 30. We're not quite there. We would probably be okay with something that was a little bit off of normal as long as it wasn't too far away. So anyway, this is a one sample test. The population standard deviation is unknown, so it's a t-test. So one sample t-test, we might state the null and alternative hypothesis. The null hypothesis is that, well, the distribution of sample means is approximately normal and that the mu equals 40. The alternative hypothesis is that mu is greater than 40. This is a right-tailed test. We're testing specifically for a higher score, not just a different score, therefore a right-tailed test. Okay, so once you've established that we have the right setup, then it's pretty easy. We just run the t-test app on the calculator. So do stat, go to t-test, tell it we have summary statistics. The mu naught is 40. That's considered normal. And we're going to test to say that it's different than, more than that. The x bar certainly is higher. So there's some evidence that it's higher, but is it enough, right, to determine that? Or is it just some random fluctuation within that normal group? So we put in 48.43 there. The standard deviation of the sample we were told was 20.76 right there. It's a right-tailed test, so we do greater than mu naught, and then we just do calculate. N was 23 there. Calculate or draw. Calculate gives you this screen. Draw gives you this one. The draw illustrates the p-value as an area, tells you what it is, 0.0322, and it gives you the t-star test statistic. The main thing we need to know is p, so that's just fine if you want to do that. More often than not, I just do this one instead. Look at the numbers. It tells me that it's a right-tailed test, which of course I told it, but it reminded me that. It gives me the t-star test statistic, the p-value, x bar, s, and n. Those three numbers in this case were something we typed in, so it's just reminding us that. But mainly there's the p-value, and that's what I really need to know. Since p of 0.03 is less than an alpha of 0.05, we reject the null hypothesis. So that we could state our conclusion. Performing a one-sample right-tailed t-test on this sample of 23 patients resulted in a p-value of 0.032. Therefore, at the 5% significance level, we see that there is sufficient evidence to conclude that patients with a mild head trauma have more psychological problems than normal as measured by this test.